So here's a January 2014 international paper. Let's just start with question 1, which should be pretty standard. There's only 1 mark for this. If ever there's 1 mark, it probably means we can just write down the answer, but let's just do it anyway. That's the same as the 2 squared times by the square root of x squared. Well, 2 squared is equal to 4. The square root of x is equal to x. So that's our 1 mark question done. The next question is rationalizing the denominator of a third. We need to change the sign, one of the signs, normally the square root 1, on the bottom, and times by that on top and bottom. Now, I see a lot of, I've just marked this, and I see a lot of effort being put into multiplying this bit on the bottom, where in fact it should always be, we should always be using the same idea, because the whole point of this is we eliminate the third from the bottom, and it's based on this principle, which we use sometimes to factorize the right hand side there, but we can use it this case when we're multiplying it out. So the bottom of this, the denominator, is equal to 4 take away the square root of 7 squared. Now the square root of 7 squared is 7. So now we're looking at the top. Now the top perhaps makes a little bit more effort. We can do the 5 times the 2, which is 10. The 5 times the minus the square root of 7, which is minus 5 the square root of 7. The 2 times the 5 the square root of 7. And the square root of 7 times by the square root of 7, or minus the square root of 7, which is minus 7. Collecting the like terms on the top, we've got 10 minus 7, which is 3. And we've got minus 5 the square root of 7 plus 2 the square root of 7, which is minus 3 the square root of 7. And that is all over minus 3. It's not fully simplified at this stage, so we need to separate it out really. 3 over minus 3. This line is not necessary to write it. I'm just writing it in by way of explanation. Minus 3 over the square root of 7 over minus 3. So obviously that 3 over minus 3 is equal to minus 1. And we've got 2 minuses happening here together. So we're taking minus, but the 3 divided by the 3 gives us 1, or minus 1. But there's 2 minuses, so that's plus the square root of 7. Okay, now let's go on to question 2. We move it up here. Okay. Question 2, it's a plain differentiation question. We need to, don't worry about this bit, it's just defining the range of the function. It's saying that x is greater than 0, but it's not going to affect our differentiation. Of course, x would have to be greater than 0, otherwise this square root thing is not defined. So that's not really important as far as answering the question goes. So a, y equals let's just write the question out, minus 4x to the minus half plus 1. Remember, we really want to get it into ax to the n to differentiate, because we want to then, we can then use dy by dx is equal to n ax to the n minus 1. I'll write that little out there. So, and now we've got it in that form, we can say dy by dx, this bit is 2 times 2, which is 4. We're taking 1 off that minus 2, so that's equal to x to the 1, minus 4 times minus half, x to the minus 3 over 2. And the 1, of course, any constant disappears. So that's that. It's not simplified as fully as possible at this stage, so let's just do that. we've got two minuses there, so it's going to be plus, and we've got a 4 divided by 2, so that's 2x to the minus 3 over 2. Okay, so that's part A. Part B, we're differentiating that again. d2y by dx squared. Now the first term is very straightforward, that's just 4, because 4x differentiates to 4. And again, plus 2 times minus 3 over 2 x, and 1 take away minus 3 over 2 take away 1 is minus 5 over 2. Not simplified yet, but here we've got the 2 and the 2 cancelling, so we're going to get a 3. And we've got a positive and a negative, so that's a negative 4 minus 3 x to the minus 5 over 2. Okay, so making reasonable progress on this paper. Right, okay, let's just look at this. It's a simultaneous equation, fairly classic. We've got a linear bit and we've got a quadratic bit here. And so we're going to use substitution from here. We can either write x as a subject to the formula and substitute the x into here, or we can write y as a subject to the formula and substitute the y into this one. I'm going to substitute the x in this case because it's going to be something not involving fractions. So if I were to substitute, I can write x. If I were to write x as a subject to the formula, I get x is 2y plus 1. And I can substitute that in there. And there's no fractions. Otherwise, I would end up with y is equal to x minus 1 over 2, which isn't too bad, but I would then have to get that in there and use fractions, which works okay. We can do either, but I'm not going to do that way. And the one advantage, I suppose, of doing it that way is I'm only substituting y in once, whereas I'm substituting x in twice into this. But I don't think it really makes much difference. So 2y plus 1 squared plus 4y squared minus 10 times 2y plus 1 plus 9 equals 0. Now let's not fuss too much on squaring out our brackets. That's 4y squared plus 4y plus 1. Now really, folks, we shouldn't be making hard work of multiplying out brackets this time. Use this basic form if you're squaring. If I need to square a bracket, square either term and then double the two terms in between. So that's what I've done here. I've squared the 2y squared to get that. Then I've done 2y times 1, which is 2y, but doubled that to get 4y plus 1. And that's equal to 4y squared minus 20y, don't forget the two negatives here either, minus 10 plus 9 equals 0. Okay, so that gives me, I'm going to break it down, 8y squared minus 16y equals 0. So the 8 cancels, or I can take it out as a factor, or I can just divide by 8 on both sides. It really doesn't make any difference. So y minus 2 equals 0. So we've got y equals 0 and y equals 2. Now we need to put that value of y back into here. So when y equals 0, x is equal to 2 times 0 plus 1. So x equals 1. So one of the points is 1, 0. And then if I do the same on here, we have x is equal to 2 times 2 plus 1. So that equals 5. So the other point is 5, 2. Okay, and that is question 3 done. Okay, question 4 is a sketching question. Let's move question 5 out of the way for a moment. Okay, let's just draw some axes and get this sorted. So looking at part A, this is a shift to the left, shift horizontally if you like. by -2, by -4 even. Because it's inside, it goes in the opposite sense. Okay, so it's going to the left. That means every y coordinate stays the same. So P, which is 4, 2, would map to P, which is 0, 2. It's all moving to the left. And 0, 3, which is also mapped in the diagram, would map to -4, 3. Okay, so if I were to draw this diagram here, okay, that's going to be move to the left there. But we need it on a separate diagram. Doesn't need to be that accurate. The shape of it doesn't need to be as accurate as I've drawn it there, but we can call that P dash, which is equal to 0, 2. And there's also another point here, which is -4, 3. Okay. But that's that -4, 3 isn't necessary from the commentary here, by the way. I've just put it in anyway. Right, now this second one is a vertical stretch. Scale factor 2. So in this case, we would have 4, 2. This time the y coordinates gets changed, so that goes up to, that gets multiplied by 2, so that goes to 4, 4. And this point here goes to 0, the x is unchanged, but the 0 goes to 6. Okay, so if I was to draw that, it's going to be, it's going to be stretched up by 2, so it's going to be more in that shape. But I don't think you need to have drawn it as like that. So the main thing is that we actually mark on the points. This is 0, 6, and this is the point 4, 4. Okay, and that's that question done. Okay, question 5 caused some problems actually. There were not that many correct answers to question 5 when I was marking your papers today, or yesterday. Note, most questions we've seen on C1 before have given an expression for U1 is equal to 12 plus 4n squared, and then you can work out U2, U3, U4 and add them all together. But notice this formula is telling us that the sum is equal to that. So all we have to do is put, for the first part, there's only 2 marks available, so that gives us a clue. The sigma 5 r equals to 1 of AR, because of it's given a formula there for the sum of it, that's equal to 12 plus 4 times 5 squared. Now 5 squared is 25, times 4 is 100, so that's 112. Okay, so then if we've got the idea of what this formula does, and it actually gives us the sum of them, not the actual individual terms, then we have got a better chance of answering this, because if we want to find the individual terms, we find the difference in the sums. So A6 will be the sum to 6 terms of AR minus the sum to 5 terms of AR, because both of these are the same, except this one has got one extra term, and that extra term is A6, which is what we want. So we can just put 6 into this formula. Okay, and we can put 5 into this formula, but that's already done in part A, put in 5 in, so we don't really need to write that out again. Putting 5 in, we get 112. Okay, so that then leads to the answer 6 squared, this is a non-calculator paper, so let's just not try and rush it too much, because if 6 squared is 36, that's 4 times 36 minus 112. So that's 4 times 36 minus 100. 4 times 30, a lot of people are struggling with their mental arithmetic here. 4 times 30 is 120. And 4 times 6 is 24. I'm writing this down, but I wouldn't normally write it down if I was actually working it out. So 4 times 4, that's 144. That's not the only way of going about that, by the way. You might have done other things. You might have said, right, okay, I know that 4 times 9 is 36. You might have doubled it and doubled it again, so you've got 72 and 144, which on reflex is better than what I've just done. Anyway, so that's 44 is the answer. Okay, now on to question 6. Okay, let's just make a bit of room for things on the right hand side. Ooh, there we go. Okay, now the gradient A is going to be straightforward. It wants the gradient of L1, and we've got this equation. If we were to write that and divide by the 3, we get 3 over 2 x plus 7 over 2. So the gradient is clearly equal to 3 over 2. And then the second part, okay, it says write down the coordinates of point A. Right, so here we're putting, if I've rearranged this, we can see it's 7 over 2 already, because it's the C in my rearrangement. Or if I hadn't have done that and I've just scanned it through, I can put x equals to 0 in here. I get 2y equals 7, which gets me to 7 over 2 also. Okay, so that's a couple of straightforward marks. If ever it says write down or state, that just literally means the mark is going to come for just writing the answer down. Okay, another straight line, L2, intersects L1 at 1, 5. So that's the point 1, 5 at point B, and crosses the x-axis at point C, as shown in the diagram. Given that this angle is 90 degrees, find an equation. Right, okay. Well, we know the gradient of L, if we call this L2, oh, it is called L2, so the gradient of L2 is minus the reciprocal. I'll write it down just for, don't have to write it, so it's minus 2/3. So we have a coordinate, and we've got a gradient of this, which is minus 2/3. So we can use y minus y1, do quote the formulas you're using, is equal to mx minus x1. Okay, so y minus, so that gives me y minus 5 is equal to minus 2 over 3 x minus 1. Right, I'm going to times through by 3 here, so I get 3y minus 15 is equal to minus 2 times x minus 1. So 3y, if I take it, that's going to be minus 2x here, which when I take to the other side will be plus 2x. This is going to be plus 2, which when I take to the other side will be equal to minus 17, which is equal to 0. Okay, so that's part B done, and slightly more work required for part C. Okay, so we're going to need some coordinates here. Let's work out the length AB first of all. The length AB will be equal to, let's call it AB squared at this case, but then we can square root it. Will be equal to, we've got the coordinate of A, which is, this coordinate here is 0, 7 over 2. So that equals to the change in y, so it's 5 minus 7 over 2 squared. Well, take away plus 1 take 0 squared. That's going to be equal to 10 take away 7 over 2, isn't it? 10, because this 5 there is equal to 10 over 2, take away 7, so that's 3 over 2 squared plus 1. That's equal to 9 over 4 plus 1. So that equals to 13 over 4. But remember, that's AB squared. So that's right. AB, I wrote it that way so I didn't have to keep writing square roots all over the place. So now we can just say AB is the square root of 13 over 4, which is equal to the square root of 13 over 2. Okay, so that's the length of AB. Now let's work on trying to find the length of BC. Well, first of all, we're going to need the coordinates of C. So that will be, remember, the coordinates of C along here, y equals 0. So we're substituting y equals to 0 in there. So we've got coordinate of C, or x coordinate of C. We'll put in 3 times 0 plus 2x minus 17 equals 0. So x equals 17 over 2. Okay, so that tells us that the length BC squared, let's do the same kind of approach so I don't have to keep writing square roots, looks slightly nicer, is equal to the change in y. Now the change in y, that's easy, that's 5 squared, plus the change in x. Now x has gone from 17 over 2 to 1. So that's equal to 25 plus 15 squared over, which will be over 4 when I square it out. So that 15 squared over 4, so that will be equal to 25 plus 225 over 4. Oh no, I put over a common denominator there earlier, thinking it getting ahead of myself. So that's 25 over 4. And that makes it 325 over 4. So let's go over to here. Let's move it over there. So that's saying that BC is equal to the square root of 325 over 4, which is equal to the square root of 325 over 2. Okay, so now we're in a position to work out the area of the rectangle. It's basically equal to AB, the length AB, times by the length BC. So that's equal to the square root of 13 over 2 times by the square root of 325 over 2. Now, a lot of people did all the work here, all the hard work, all the nitty-gritty accurately to this point, and then try to do all kinds of things. I saw people try and do 13 times 325 and then work out the square root of that. It's much harder. Now, it's a calculator paper. It's talking about an exact value. I just have a sense here in this type of question that this is going to break down. Now, 325, you might not think is particularly promising, but we can see it's got a factor of 25. So if you divide that by 25, you can see that that's 13. So that should help us, because we have the square root of 13 over 2 times by the square root of 13, the square root of 25, all over 2. And then the top, the square root of 13 times by the square root of 13 is equal to 13. The square root of 25 is equal to 5, and that's over 4. So that makes it 65 over 4. Okay, now on to question 7. Okay, so question 7 is a series question, a little bit to take in here. It's an arithmetic series question, as I've said, and yeah, I mean, we've got Salim's starting salary is 1,400, so that gives us A is equal to 14,000, should I say, and has a raise of 15,000 every year. Well, not 15,000, gone the other way now, 1,500 or 1,500 every year. So that he will have a salary of 15,500 in year 2 and so on. When Salim reaches 26,000, he will receive no more rises. His salary will remain at 26,000. So that Salim will have a salary of 26,000 in year 9. We can either work out that when his salary is 26,000, n equals 9, or we can put in n equals 9, and so it's 26,000. I'm going to do that. When n equals 9, U9 equals to 1,400 plus 9 minus 1. It's probably a good idea to quote the formula as well, just tell the examiner what we're doing. 9 minus 1 times by D, which is 1,500. So that's 14,000 plus 8 times 1,500. Now, we know that it's meant to get 26,000, but again, just doing a bit of quick mental arithmetic, double that, we get 3,000. Double it again, we get 6,000. Double it again, we get 12,000. I've missed a 0 out of there. So add those together, and we'll get 26,000. Okay, as required. So but we can go the other way. So for those of you who put in 26,000 into this formula and then showed that n is 9, that's fine too. Okay, B, find the total amount Salim will earn in his job in the first 9 years. It's probably easier to use the A plus L formula here. Some people use the other one with the 2A plus n minus 1D, but because we know A and L, and they've told us this, it's so there's no danger that we've got these two numbers wrong because they're given in the question. It's probably easier to do that. So we've got 8 over 2 times by plus. Okay, so plus 26,000, should I say. Okay, oh, it's not 8 over 2, of course, it's 9 over 2, because n is 9. And that gives us 9 over 2 times by 14,000 plus 26,000, which is equal to 40,000. Again, remembering this is a non-calculator paper, so I would be dividing this 40,000 by 2, getting 20,000, timesing that by 9, getting 18,000. Okay, let's move question 8 out of the way for the moment. Right, so that's part B. Part C, 6 marks here, so there's going to be a lot more work involved, I'm sure. It says that Anna starts on a new job on some unknown salary, we're calling A, but her raise every year is £1,000 every year, so that she has a salary of A plus 1,000 and so on in the few years. It says the maximum salary for a job which is reached in year 10 is also 26,000. Okay, so we can use the two formulae. So for the sum, we know that the sum we know that UN, U times by we know that U time is going to be the same salary, 26,000. We know that the U9 has got to be 26,000. Okay, so we've got U10 is going to be 26,000, should I say? Okay, so we're then working out what the value of A is for that. So we'll get it, if we use the UN formula, UN is equal to A plus N minus 1 D. We can put that in. We want to find what A is when given that N is N is 1 and D is 1,000. So A is equal to 20, is equal to, if we work that out, minus 9,000, which is 17,000. Okay, so that's the first part of the question. Then it says find the difference in the total in the first 10 years. Now, we've got to be a little bit careful here because we've got Salim will have earned in 10 years the amount that he's earned for the first 9 years. But then, of course, it's not gone up anymore after that. So plus the salary in year 10. Okay, so that will be 206,000 as a total, because it stayed steady after 9 years. However, Anna, as we can use the SM formula because Anna has taken 10 years to reach that salary. So at Anna, we can do 10 over 2. The starting salary, as we've worked out, is 17,000 plus the final salary, which is 26,000, and that, when we work it out, is equal to 215,000. So the difference between these two is equal to 215,000 take away 206,000, which is equal to £9,000. Okay, so that's that done. Incidentally, working this out, if you're wondering how to work that out, I'd probably add the two numbers together. So you get 43,000, and then half that, and you get that's where you get the 215 from. Okay, let's go on to question 8. Okay, first part is standard discriminant. Because it's two distinct roots, we can say that b squared minus 4ac has got to be greater than 0. Not equal to 0 because of the distinct part of it. So then we can say that 2k squared, take away 4 times a, which is 2, times by c, which is k plus 2, greater than 0. So it gives me 4k squared minus 8 k plus 16 is greater than 0, which is k squared minus 2k minus 4 greater than 0 as required. Okay, part B, solve the inequality. Some people imagined it always factorizes. Obviously here, it doesn't here. This expression does not factorize. So some people desperately tried to factorize it and then came up with something that was wrong. Often they do these factorize them, but this one doesn't. So first of all, we need to find critical values. And to solve that, we just solve the equation where it's equal to 0. So almost ignore the inequality and work out the critical values, which it's all to do with first, and then deal with the inequality afterwards. So I'm going to complete the square here. You can use the quadratic formula if you want, but completing the square is going to work out quite nicely because it's an easy number. If you're at half in an even, it's always pretty easy. So take a half 2, which is 1, take away 1 squared, take away 4 equals 0. Okay, that gives me k minus 1 squared minus 5 equals 0. Okay, so that gives me k minus 1 squared equals 5. K minus 1 equals 2 plus or minus the square root of 5. So k equals 1 plus or minus the square root of 5. Those are my two critical values. Right, okay, so now there's two ways of going about this. Now I tend to use a number line approach. Some people use a graphical approach. Put these two numbers on the number line. 1 minus the square root of 5. Now, you don't know exactly what that number is because it's not in a calculator, but you know that it's negative, for example, and you know that it's going to be less than, you know that minus 3 will be smaller than that because, yeah, or minus 2 even. You know that minus 3 will be smaller than that. You know that minus 3 would be over here, for example. And 1 plus the square root of 5. Again, you don't know what it is, but you know it's some number above 3. Okay, so looking at this, if we find where the values are in the bracket, we'd find that if we put in a number minus 3 into this expression, say, we'll find that it is negative. No, we'll find it's positive, so let's say, because minus 3 squared minus 2 times minus 3 minus 4 is equal to 9 plus 6 minus 4, which is positive. So it goes from positive to negative, positive which is greater than 0, to negative which is less than 0, to positive which is greater than 0. But we want it to be positive because we're solving this inequality. So that's telling us that k has got to be in between these two values here. Okay, so that's one approach to it. The other approach, which also works fine, is to do a graphical approach and just plot the graph. And then if you plot the graph of this, we can see it's going to go like this, with this being 1 plus the square root of 5, and this being 1 minus the square root of 5. And we want it to be above. Also, I've got the actual thing the wrong way around, of course. We want it to be above. So we've got k has got to be less than 1 minus the square root of 5, and k has got to be greater than 1 plus the square root of 5 in order for it to be positive. So either what, take your pick there, either one is fine. Okay, let's get on to question 9. It's an integration question. So we've got f stroke x is equal to x minus 2, 3x plus 4. If we multiply that out, we get 3x squared minus 6x plus 4x. So that's minus 2x minus 8. So if we integrate each term, we've got fx is equal to x cubed minus x squared minus 8x. Don't forget the constant. Okay, a few people forgetting the constant here. And that we can work out the constant. If we're given a point, we can work out the value of c. We've got f3 is equal to 6. So we have 6 is equal to 3 cubed minus 3 squared minus 8 times 3 plus c. So we have 6 is equal to 27 minus 9 minus 24 plus c. Okay, so that gives me c is equal to 27 take 9 is equal to 16. No, 18. Take away 24, which is 6. So I think that gives me c equals to 12. Okay, so minus 9, 24 equals to 12. Yeah. Okay. So we really should be writing our polynomial now as with c written in it. So fx is equal to x cubed minus x squared plus 8x plus 12. Okay. Right, now it's told us basically that this factorizes. Now it may seem unpromising here, but we've already got a lot of information here. We know that the last term is 12, and we know that this bit squared, if I was to multiply that out, that's fx is x squared. Let's write it out to try and explain what I mean. But we need the final coefficient to be equal to 12. So these two need to multiply to 12. So we get 4p equals 12. So p equals 3. So that's the answer to that question. And then finally, a nice bonus really, once we've got the factorized form, we've now got all the factors to this. So we now no, this is repeated, so that means it touches. Okay, we know it's doing this because it has a positive term in x cubed. So that pretty much sorts out. We also know it's going to go through 12. So that pretty much clears it up. And we know it goes through minus 3. Okay, goes through minus 3 here, goes through 12. And it's got a repeated 2 there, 12. The only thing I don't know there is if I've got the maximum or minimum the right way. I suspect it's the wrong way, but it doesn't matter. It's not asking for that in this case. Actually, looking at it, it probably is that way. But if you'd written if the maximum was the other side of the axis in this question, it wouldn't matter. We've got our main features that they're looking for. Okay, so we're on the final question of this international paper. Right, now, so it's tangents question. It's actually first few marks are pretty straightforward, really. In fact, sometimes that happens, we think that it's going to get harder and harder, and then just basically gets a little bit easier sometimes. So the equation of tangent is this. So we need to find dy by dx, which is equal to 3x squared minus 4x minus 1. So when x equals 2, dy by dx, now I know it's got to be equal to 3, so if I don't get it equal to 3, then I know there's something wrong. So that's going to be, this is equal to 4, that's 12, take 8, which is 4, take 1, which is 3. So now I can just use y minus y1. They've also given me both the x and y coordinate of this. So that's also pretty straightforward. So I've got y take away the 1 is equal to 3x take away the 2. So that gives me y equals 3x minus 5 as required. Okay. So that's just the final 5 marks to go. It says the point C also lies in C. So what we've got is a tangent at the point 2, 1 for this cubic, different cubic to the one before, also meets again. So what we need to say is that no, sorry, it doesn't. It says the tangent is parallel to C. It doesn't say it meets it again. I was thinking of a different question. So it says it's parallel to the tangent. So we want, when the gradient, if it's parallel, the gradient equals to 3. So we've got an expression for a dy by dx. So we've got 3x squared minus 4x minus 1 is equal to 3. So that gives me 3x squared minus 4x minus 4 equals 0. That factorizes. I know that plus 2 is going to be minus 2 is going to be a factor. And plus 2 is a factor, I think. Minus 6x plus 2x, that's right. So that factorizes it, equals to 0. That gives me x is equal to minus 2/3. There's no need to work this one out, because that's the point we started with. That's our 2, 1 that we started with. That's one of the points where the gradient is equal to 3. So all we need to do now is sub minus 2 over 3 into the original equation. So we've got, let's look at y equals to minus 2 over 3 cubed minus 2 times minus 2 over 3 squared minus 2 over 3 plus 3. Okay, so that's going to be a little bit of work, but we shouldn't be too bothered with this. Minus 8 over 27 will be that bit. This will be minus 2 times by 4 over 9, so that's minus 8 over 9. This bit, the two minuses are going to cancel, so that's plus 2 over 3 plus 3. So now we're into our non-calculator thing. Can we work without a calculator effectively? Let's put them all over a common denominator of 27. So that's going to be 8 over 27, 8 over 9, which is 24 over 27 times by 3, plus 54 over no, not 54, is it? It's times by 9, plus 18 over 27. plus 27 times 3, so that's 81 over 27. And finally, that comes to 67 over 27. So our point that we required is minus 2/3 and 67 over 27. So that's it. Paper done, completed in just over 50 minutes with a little bit of mumbling on the way. Hope that's fine and we've cleared up any issues you might have had. Thanks, bye.